Assalamu alaikum. Today the topic of discussion is differentiation. So first of all, we define a differentiation and learn who differentiation by graphically, and then we understand some rules of the differentiation, and after that we solve some problem. So graphically, let's suppose this is our x and y coordinate system. So on x-axis we take the independent variable, and on y-axis which one is dependent. So on x-axis, let's suppose we have a point which one is equal to x, and correspond will be let's suppose this is our point P, and you know about point is completed with the help of x and y coordinate. So on y-axis we plot this one, and this becomes your y, and we can write it f of x. Why f of x? We know about y is equal to f of x. Y is a function of x. So we can write any point in the form x and f of x in the place of y. So if we change some, let's suppose this is our x, and let's suppose we take a point which one is equal to change in x, and it becomes x plus del of x. So similarly, on the y axis also change will be appear. Let's suppose this is our new point which one is equal to q, and correspond this will becomes f x plus del x, because variable will be changed. So if we define differentiation in one word, differentiation mean a change, and obvious thing, change will be appear in any variable, because constant is any constant fixed value. So we can join this one, and any about graph will be appear. So this is basically a differentiation. Now I define it becomes dy over dx. It d means differentiation, it is a notation, and it will specific for any change. So change will be appear in y with respect to x. So it will be a limit mean approaching value. So approaching value is del x approaches to 0. So it becomes fx plus del x minus f of x, and divided by x plus del x minus x. It is like that we define gradient which one is equal to y2 minus y1 over x2 minus x1. So similarly, let's suppose this is our y2, this is y1, similarly this one is x1 and it is x2. So put in this relation, and we define the definition of the differentiation. Okay, so if we understand differentiation, it is basically m is equal to rise over run. So you know about run is along the x-axis, and rise will be on the y-axis. So that's why we written in this form the definition of the differentiation. And this is mathematically form, and we write it as dy over dx is equal to y prime. It is also a notation of the differentiation. Okay, so next we define the rule of the differentiation. So rule number one, it is called power rule. Okay, the rule is, let's suppose we have a function which one is equal to y, and it is equal to x raised power some m, and we want to find the derivative of this function. So it becomes dy over dx, and so here we apply the operator which one is linear operator, and it is a differential. So it becomes x raised power m. Okay, now we apply here, and it becomes y prime, or you can write dy over dx as it is. So power rule is that power will be appear here m, then minus 1 m minus 1, and then we have to take the derivative of the base. So in this case base is x, so we have to take derivative dx with respect to x. So the answer of this will be 1, so it becomes m x raised power m minus 1 into 1. So the derivative of this function y prime is equal to mx raised power m minus 1. So this is a power rule. Now we take any specific example. Let's suppose uh, we have y is equal to x raised power 7 and we have to differentiate it, so it becomes dy over dx, which one is equal to power will be here 7, and then we have to remove 1 from power, so it becomes 7 minus 1, and the derivative of the base, so base is in this case is x and we have to derivative with respect to x, so the answer of this will be 1, so it becomes 7x raised power 6. So this is a power rule, and I tell you a related example to the power rule. Okay, so second rule is rule number 2. Rule number 2, which one is equal to product rule? Product rule. So product rule is, let's suppose y is equal to any two function and which are dependent on the x. Let's suppose u is also function of x and any function v which is also function of x, and we have to differentiate, so we can y prime, so in the form of product, because both function are in the form of product. So first of all we take the derivative of first function and second will be as it is. It means u prime of x and v of x will be as it is, then plus. Now first function will be as it is. Function is basically u of x. Why u of x? Because in this case our function is depend on the x, and the second function we have differentiated. In any simple case we can write here y prime is equal to, we can write here the derivative of the first function, so this one, and v of x will be as it is, plus u of x will be as it is, and derivative of the second, so dv into x over x mean function of the x, so it means d of x. Now we take example of any question related to product rule. Let's suppose we write a function y which one is equal to let's suppose x plus 1, and here x raised power, no, sorry, x square root. Okay, we have to differentiate it. We can write apply derivative. So the derivative of this function, we already know the derivative of x will be 1, and the derivative of constant, so I am writing here d over dx, or any variable x y z constant means c is equal to 0, because we can find just change in the variable. Any constant will be fixed, so derivative of any constant will be 0, so here will be 0, and the second function x square root will be as it is, plus. Now our first function will be as it is, which one is equal to x plus 1, and we have to apply derivative of this one, so we can write here d over dx x raised power 1 over 2. Now x prime, it will multiply this one, it becomes x square root plus x plus 1 will be as it is. Okay, we have to find the derivative of this one, so first of all here we apply the power rule. Power will be in the start x raised power 1 by 2, then minus 1, then derivative of base, so our base in this case is also x. Okay, so it becomes x square root plus x plus 1, and 1 by 2 will be as it is. So if we solve it, it becomes x raised power minus 1 by 2, and the answer of this one will be 1. So it becomes x square root plus x plus 1, and we can move in the denominator, so it becomes 1 over 2x square root, and this is your y prime derivative. So in this way we can apply our product rule to any specific question problem in the differentiation. Okay, hope you are understand. So next one is third rule, which one is equal to quotient rule. Rule number 3, quotient rule. What is quotient rule? Let's suppose we have a function and it is in the form of quotient or in fraction. Let's suppose our function is u, which is depend on the x. Similarly, we can v, which is depend on the x. Okay, what is quotient rule? Quotient rule, it is very important rule and help in the differentiation. So quotient rule is we have to apply derivative. Okay, so quotient rule is we have to take power 2 of the denominator. So in this case denominator is v of x, so we have to take power 2 of the denominator. So in the numerator, denominator will be as it is, and we have to apply derivative of the numerator. So derivative with respect to x, u of x, then minus, and our numerator will be as it is. So in this case numerator is u of x, and we have to apply derivative of the denominator, not power of denominator, just denominator. So our denominator is just v of x, so d over d of x v. So in this case we apply quotient rule, and the mechanism of the quotient rule I have discussed. So u of x, u simply you can write u minus u, and dv over d of x. So this is our quotient rule. Now we solve any example related to quotient rule, you can more understand. Let's suppose we have an example. Example is which one, y is equal to, let's suppose y is equal to 3x minus 1 divided by x raised power 1 over 2. Okay, we have to apply quotient rule. So quotient rule, it become dy over dx. So rule said that we have to take the square of the denominator. So in the case of denominator 1 by 2, this is our denominator, and we have to power 2. So now in the numerator, denominator will be as it is, so 1 by 2, and now we are able to take direct derivative. We can take derivative of this one. So derivative of this one will be 3 minus, now numerator will be as it is, so 3x minus 1 will be as it is, and we have to take the derivative of the denominator. So in this case this is our denominator. So now the derivative of the denominator power will be start here. We apply the power rule. So 1 by 2 x raised power 1 minus 1 by 2, and the derivative of base is 1. Now we can write here, this will be cancel out, so it becomes 3x raised power 1 by 2 minus 3x x minus 1, and this becomes 1 over 2 into x square root. So and divided by x will be as it is. We can write here 3 x square root minus 1 by 2 x square root, and 3x minus 1 divided by x y prime. So this is rule number 3, which one is called quotient rule, and it is very helpful to find the derivative of any function. Okay, now we learn about two important derivative of function. One function is exponential function. Okay, let's suppose we have function y is equal to e raised power x. This is called exponential function. How to find the derivative of the exponential function? So first of all, we apply the derivative of the exponential function. So exponential function will be as it is, so e raised power x will be as it is. Now we have to take log of the base. In this case, base is e, so we have to take log of e. Now the next step is, first one is exponential function will be as it is, so second one we have to take log of the base, so in this case base is e. Then third one we have to apply the derivative of the power, so in this case power is x and we have differentiate with respect to x, so dx over dx, so it becomes e raised power x, and we know about log of e is equal to 1, so this is 1, this is 1, so the derivative of the exponential function will be as it is. But if exponential function in this form, let's suppose we can write exponential function y is equal to e raised power 3x. So in this case we apply derivative of the exponential function, so exponential function will be as it is. We have to take log of base, so base is e. Now we have to apply derivative to the power, so d over dx, and this will be as it is. So e raised power 3x log of e is 1, so here is 1, and 3 is a constant and it is will be written here, so it becomes dx over x. Because any constant we can separate from the derivative, so the answer of this one will be 1, so it becomes e raised power 3 of x 1, then 3, this will be 1. So the final answer of this exponential function, derivative of this exponential function will be 3 e raised power 3 of x. This is our y prime. Okay, we consider another example. Let's suppose y is equal to e raised power minus 4 of x. We have to differentiate, so we can write y prime. So exponential function will be as it is, minus 4 of x log of e, then derivative of the power. So in this case power is minus 4, minus 4 of x. So e raised power minus 4 of x will be as it is, log of e will be 1, and minus 4 will be outside to the operator, so minus 4 and dx over d of x. So it becomes minus 4 e raised power minus 4 of x y prime. Okay, let's suppose what is exponential function. Exponential function is basically constant raise some power and your power is variable. Let's suppose y is equal to 5 raised power x. This is also exponential function. And how to calculate the derivative of this function? So it becomes y prime is equal to, this will be as it is according to exponential function, 5 raised power x log of 5 and derivative of the power. So 5 raised power x will be as it is, and now this is log of 5 not equal to 0, so it will be as it is, log of 5, and the answer of this one will be 1, so it becomes 5 raised power x log of 5. This is a derivative of any exponential function in place of e. Log e 1, but log 5 log 3 does not equal to does not equal to 1. not equal to 1. Okay, so d over d of x. Here is 1. Mean to say that log e is equal to 1, but log 5 not equal to 1. So we cannot write here 1. So log 5 will be as it is. So this is the end of demo. Hope you are understand. Thank you.